Today we are going to see bleaching with sodium chloride. In the last class we have seen sodium hypochlorite bleaching. Sodium hypochlorite is a very powerful oxidizing agent that gives good bleaching to cotton materials, but the problem is it is in the alkaline medium, so we cannot bleach the synthetic fibers. Normally the synthetic fibers will dissolve in alkaline medium, so it is you need to do the bleaching in alkaline medium, acidic medium. So sodium chloride is another oxidizing agent that gives the bleaching in acidic medium. Normally the sodium chloride is stable in alkaline medium. It should be activated to bleach to liberate the oxidizing agent. So normally it it gives oxidizing power below 6 pH 6, and if you reduce the pH it will increase the oxidizing power, and below 2.5 the pH 2.5 it produces chlorine gas, so that that will not give bleaching power to the material. So the bleaching should be done below pH 6, and it should be in the range of 3.5 to 4 for best bleaching. And the bleaching is done at alkaline acidic medium, so we can bleach the cotton material and synthetic material, but we cannot bleach the wool and silk. It gives a pink tone to the fabric, so it is better to bleach the cotton and synthetic materials like polyester, nylon, and PC blended fabrics. So it gives less damage to the cotton fibers when compared to sodium hypochlorite bleaching, and it liberates less AOX. So when compared to sodium hypochlorite bleach, the active species for bleaching is hypochlorous acid. Bleaching with sodium chloride. So the chemical structure for sodium chloride Na. So in acidic medium, that means below pH 2.5. So by using HCl, hydrochloric acid, so it gives NaCl and hypochlorous acid. So this hypochlorous acid is a very weak acid, so it will not give bleaching. So it will give bleaching only in alkaline medium. So this is not suitable to bleach the cotton fabrics. Whereas, so the bleaching power gives only below pH 6 and above 2.5. So during that period it will produce chlorine dioxide gas. So that is the oxidizing agent for sodium chloride bleaching. So this will happen when the pH at 2.5 and below this range, it will start producing hypochlorous acid. So that is the very weak acid that will not give bleaching to the cotton fabrics. Whereas above pH greater than pH 3.5 to 6, so it start producing chlorine dioxide. So it will produce chlorine dioxide. So that is the powerful oxidizing agent that bleach the organic matters present in the cotton materials. That is that will bleach that will reduce the that will oxidize the natural coloring matters present in the cotton fabrics. So at pH 1 to 2, so the production of chlorine dioxide is very rapid. So very rapid. So it will not help to bleach the cotton fabrics, whereas in the range of 3.5 to 4, so is the optimum range for bleaching of cotton fabric with sodium chloride. So this is the optimum range to bleach the cotton fabric with sodium hypochlorite, and above this range there is a reduction in bleaching, and above 6 there is no bleaching, so it will stable in alkaline medium. So normally the sodium chloride should be activated. Normally it comes in alkaline conditions. So it is stable in alkaline medium, so it comes in alkaline medium. So for bleaching we have to activate this sodium chloride by using any acid or acid liberating agents, normally formic acid, tartaric acid, phosphoric acid, tartaric acid, maybe use it to reduce the pH of the bleaching part to 3.5 to 4. The AOX produced by this method is very low when compared to sodium hypochlorite, so it is 1 by 10th of the sodium hypochlorite, so it is very low when compared to sodium hypochlorite, and the removal of motes is very good in the case of sodium chloride when compared to sodium hypochlorite. The redox potential is around 1042 1200 millivolt. So it is a very good power oxidizing agent. So bleaching is done at 70 to 90 degrees Celsius for 1 to 4 hours. So this is the condition for bleaching, and temperature will not influence the bleaching. That means if you reduce the temperature, it will reduce the time to bleach the cotton fabric. Sorry, it will increase the time to bleach the cotton fabric. If you increase the temperature, it will reduce the time of process. So here the active bleaching agent is chlorine dioxide. So it is a toxic agent, and corrosive in nature. So it is toxic and corrosive in nature. So this is the main disadvantage of this process. So to avoid corrosive in nature, we have to use stainless steel vessel to bleach the uh, material. So we have to use stainless steel vessel, otherwise it will corrode the bath, and it will scavenging the chemicals. So we have to use scavenging agents like sodium nitrite or sodium or ammonium nitrate, nitric acid, and melamine is used as a scavenging agent. Um, the advantages of this process is you can use this bleaching agent for cotton and synthetic, So whereas sodium hypochlorite is not suitable for a synthetic material, so it will degrade the polyester in alkaline medium. So whereas sodium chloride is an acetic medium, so we can bleach the cotton material as well as synthetic material. And the next one is used in an acetic medium. So the bleaching takes place in acetic medium, so the hardness of water will not influence the process of the bleaching. So hardness water is not affect the process. And it will produce soft feel and excellent bleaching and moss removal, and very little cellulose degradation. When compared to sodium hypochlorite, and it is inactive in metals against the metal. And disadvantages, so it is expensive than sodium hypochlorite and hydrogen peroxide. So you cannot bleach woolen silk, so corrosive in nature and toxic. So it is done at acetic pH. So the wax removal is very less. So these are the disadvantages of this process. And for sodium hypochlorite and sodium chloride, we need anti-chlor treatment to dye the fabric. So for anti-chlor treatment, so it is the main objective of anti-chlor treatment is to remove the residual chlorine present in the cotton fabric. For anti-chlor treatment, we can use sodium thiosulfate or oxalic acid at 85 to 90 degrees Celsius for 1 hour. The next oxidizing agent, that is a hydrogen peroxide. So it is used as a bleaching agent, bleaching with hydrogen peroxide H2O2. So this hydrogen peroxide replaces the other oxidizing agents like sodium hypochlorite and sodium chloride. So because it can bleach cellulosic material and synthetic material and even woolen silk. So because of these properties, it is called as universal bleaching agent. So because it can bleach almost all the fibers, so it is called as a universal bleaching agent. Normally it is pure white in color. It is supplied in dark containers to avoid the decompose of hydrogen peroxide with the sunlight. So it is stable in acetic medium. So it is stable in acetic medium, and in alkaline medium it start liberating oxidizing agent. So the active oxidizing agent is nasal oxygen. as an oxygen is the bleaching agent for hydrogen peroxide. So for example, if you take hydrogen peroxide and decomposes into hydrogen and HO2 ions, this HO2 again decomposes into HO plus an oxygen. So this is the very powerful oxidizing agent. So in alkaline medium, so this reaction takes place at pH 10.5. The redox potential is 810 to 840 millivolt. So it is much lower than the sodium chloride and sodium hypochlorite. And bleaching should be activated with alkaline medium. So activated with alkaline. So normally for activation we use sodium hydroxide, NaOH. So it gives oxidizing power to the sodium hypochlorite. So it increases the pH to 10.5 to 10.8. And for bleaching, we need to stabilize the liberation of perhydroxyl ion. So we have to control the perhydroxyl ion, otherwise it will decompose at very fast rate. And similarly it will oxidize the perhydroxyl ion. So we need to stabilize the perhydroxyl ions by using sodium silicate. So stabilize it, we need to add into the bleaching path. So normally for stabilizing we use sodium silicate. So normally the sodium silicate mixture of Na2O and sodium silicon dioxide SiO2. So it is in the range ratio of 1:1. So the stabilizer, the function of stabilizer is to control the rapid decomposition of perhydroxyl ion. The advantages of sodium hydrogen peroxide bleaching is you can combine the scouring and bleaching process in a single step. So you can combine scouring and bleaching in a single bath or single step. And no need of anti-chlor treatment, no corrosive nature, and it is non-toxic, and there is no AOX problems. Advantages: you can bleach almost all fibers. Disadvantages: so silicate is used as stabilizer, and this silicate will choke the membranes. So RO membranes in effluent treatments. And catalytic degradation in the presence of metal ions, and not very effective on synthetic fibers. on synthetic fibers. The recipe for bleaching with hydrogen peroxide is H2O2 4%. For alkaline medium, we use sodium hydroxide 2%, sodium silicate 1%. Even we can use sodium carbonate 2%, wetting agent 0.5% at 90 degrees Celsius for 1 to 4 hours. So we can increase or decrease the time by increasing and decreasing the temperature of the bath.